All right, here we go, section 2.6, graphing rational functions. We're going to start this lesson off by going back to our vertical and horizontal asymptotes that we did back in chapter 1 and finish up with domain. So, first of all, when we are trying to find the vertical asymptotes, if you remember this from, like I said, chapter 1, vertical asymptotes are wherever the denominator is 0, and we're going to write these as equations of lines. Because they are vertical lines, they are not part of our graph, but they are vertical lines. They're imaginary lines. So vertical asymptotes in this case, we have 1, and it occurs at x equals 3. That is what makes the denominator 0. The horizontal asymptote, for everything we do, we will only have one of these or none. There is the third case where the numerator has a greater exponent than the denominator. And this means that there is no, we'll abbreviate, horizontal asymptote. And basically what that means is that there is a slant asymptote, but that is not something that we will be graphing. We will only graph horizontal asymptotes. The last thing we're going to look for here is the domain. And remember, your domain is all of the numbers from negative infinity to infinity, just taking out all of the problems that we have. So in this case, the only problem we have is a positive 3. So the only issue we have here that will cause an undefined in this fraction is a positive 3. So our domain will go from negative infinity to 3 with a parenthesis, and then from 3 up to positive infinity. So we want to write that in interval notation there. So there is your bell ringer warm-up. Now, for these steps, we're going to do all of these different things, and then we'll put it all on the graph. So I'll just run through this again real quick. You can make your little side notes here. So finding x-intercepts. How do we find x-intercepts? Well, the x-intercepts occur where the numerator, so we'll abbreviate this, the numerator is equal to 0. Y-intercepts, to get the y-intercepts, we plug in 0 for, that's supposed to be it, f for x. Okay, so plug in 0 for x and simplify. Removable discontinuities and vertical asymptotes start off the same way, and that is, this is where the denominator equals 0. But then the removable discontinuities, this has a matching factor on the top. So the way that we did this was we said that it would cancel. We don't actually cancel it, but it would cancel. Basically just meaning that it has a common factor up top. Vertical asymptotes, again, start off the same way. The denominator equals 0, but then this one does not cancel, just meaning that it does not have a common factor on the numerator. The horizontal asymptote, there will only ever be one. We have two cases here. We either have the case where the numerator's exponent is less than the denominator's exponent, meaning that we have a bigger power on the bottom, and in that case it'll always be the line y equals 0. Or the other case is where the numerator and denominator have the exact same exponent, and when we do that, we wrote this as a over b, which just means we are dividing the coefficients out front. So then we're going to make up a sign chart to get a general idea of what the graph looks like. And then finally, we will put all this information on the graph. So let's go ahead and do these two examples here. We'll make the list. I'm going to make my graph in blue. So everything you see here that is in blue will be part of the graph. I'll do my vertical asymptotes in red, which is indicating that they will not be part of the graph. So we're going to draw them here, but if you were to graph these on like a graphing calculator or some kind of graphing utility online, you will not actually see the vertical asymptotes on that. It's not part of the graph. They're just guides that the graph will follow. So x-intercept. Actually, before I even do anything here, let's go ahead and factor this. The top is already factored, that's x plus 6. But the denominator, we will make this x plus 2, x minus 1. That's not a 2, that's supposed to be a 3. Sorry, I was looking at the middle number there. So x plus 3, sorry. So we're looking for two numbers that'll multiply to give us -3, add to give us 2. So that's going to be a +3 and a -1. So x-intercepts. There are no limits on your x-intercepts. You could have no x-intercepts. You could have 1, 2, 3, 4, 5. There are no limits to that. In this case, the x-intercept, we only have one of them, and that is what makes our numerator 0, and that is a -6. Okay, so we want to write these as points. They are intercepts. They are points on the graph. So -6, 0 is our x-intercept. The y-intercept, you only have two options for y-intercepts. There is either no y-intercept, which means that we have a vertical asymptote on the y-axis, or there is only one y-intercept. You can't have more than one. Okay, if you have more than one, it's not a function. So the y-intercept is what we get when we plug 0 in here. So if you plug in 0 into this function, you end up with 6 over -3. And 6 divided by -3 is just a -2. Next up, we will do our asymptotes. So, well, first of all, let's look at the removable discontinuity. It doesn't exist here, but removable discontinuity would be what makes the denominator 0. So x equals -3 is a 0, and x equals 1 is a 0. The removable would be if one of these was also in the numerator. Okay, so if we had an x plus 3 or an x minus 1 in the numerator, that would be removable. Okay, so we don't have that case here, so we're just going to write none or NA or DNE or whatever. There is no removable discontinuity. Vertical asymptotes then are the zeros in the denominator that do not have a pair or a matching factor up top. So we have two of them in this case. We have a -3 and we have a 1. The last thing we need to do before we go to our sign chart is the horizontal asymptote. So we look at our exponents. I have an exponent of 1 up top and 2 on the denominator. So that means the numerator has a smaller exponent than the denominator, which means it's y equals 0. And again, it will always be 0. If your top is a 2 and the bottom exponent is a 5, doesn't matter, it will always be 0. Okay? It doesn't matter what the exponents are. If you have a bigger exponent in the denominator, the horizontal asymptote is always 0 for what we are doing. And again, the reason why is because the denominator is growing so much faster than the numerator. And if you have a bottom-heavy function, you have a rational function where the denominator grows much, much faster than the numerator, that will always be approaching 0 as you get further away from the y-axis, okay, as you plug in bigger and bigger x values. Okay, so let's go to our table now. So I'm going to go ahead and just kind of put a little line there to separate all this. So for my table, when we did our sign charts before, we only included x-intercepts. Okay, when we're doing these now, we not only need x-intercepts, but we need to include removable and vertical asymptotes. Okay, so we're going to put these in order up here from least to greatest. So the smallest one I have here, whoops, my pen was freaking out for a second. Let me back up here. Back up. There we go. So the smallest one we have is a -6. And remember, we always want to start off with a space to the left. The next one I have is a -3, so I want a space between. The next one I have is a +1. And then I need something bigger than 1. Now these, I'm just going to cross these out. I'm not concerned with those columns, so I'm not going to include them in my work here. All I need to do is find some numbers that are less than and in between all of these. So I'm going to pick a number less than -6. Take your pick here. It doesn't really matter. I'm just going to use -8. A number between -6 and -3. I'm going to say, let's use -4. A number between -3 and -1. Again, you could choose any number you want to, but 0 is a really good number, mainly because the math is easier, but also because we just did it right here, so we don't have to redo that. We already have it done. And then I need a number bigger than 1. Let's say, I don't know, 5. All right, now, when we do this, we want to plug our numbers into the factored form. And all we are checking is, we just want to check and see, is the overall answer positive or negative? Okay, so here's my fraction bar. Up top, -8 plus 6 is negative. And on the bottom, -8 plus 3 is negative. And -8 minus 1 is negative. So overall, my final answer here, 3 negatives means negative. All right, moving on. Next one, -4. Up top, -4 plus 6, well, that's positive. -4 plus 3 on the bottom, that's a negative. And -4 minus 1 on the bottom is another negative. 2 negatives, a negative times a negative is a positive. Okay? For this next one here, 0, again, I don't have to do any work for 0 because I already did it over here, and I already know that 0 gave me a -2, so I'm just going to fill in a negative sign there. Okay? So let's get rid of this. Last column we need to do is I chose a 5. Again, you could choose any number you wanted to that was greater than 1 and plug them in here. So 5 plus 6 is positive. 5 plus 3 is positive. And 5 minus 1 is also positive. We have 3 positives. That will overall be a positive. Okay, so this is all of our information. We have now gone through our entire list here, found all of these different pieces, so we will go ahead and put this all on a graph now. So I'm going to start off, I'm going to start off with, I'm going to put the grids in black, my vertical and horizontal asymptotes in red, and then my actual graph will be in blue. So I have x-intercepts at -6, so I'm going to go 1, 2, 3, 4, 5, 6. I'm going to put an extra one here. And I have vertical asymptotes at -3, which I got there, and then at 1, so I'm going to put an extra one here, and a y-intercept at -2. All right, filling in my vertical asymptotes. I have a vertical asymptote at -3, so 1, 2, 3. So right there, roughly. And again, I'm making that a dashed line because it is not part of my graph. This is just a guide that the graph will follow. Same thing at +1, dashed line at +1. Not part of my graph, just a guide my graph will follow. Let me actually put my x-intercept and y-intercept on here. Okay, so now I am ready for my horizontal asymptote. Okay, the horizontal asymptote is at y equals 0. Now, if you're just using a pencil, when you graph over this, just make it a little bit thicker than the line so I can clearly see it. Here, I'm going to use a different color so I can clearly see that here. But if you're using a pencil, just make it a little thicker so I can see that you have a horizontal asymptote there. All right, so before I put the graph on here, I just want to point out one thing. Vertical asymptotes are undefined, okay? Your graph cannot cross over or touch a vertical asymptote. They are simply guides. Think of them as like a wall. It's a brick wall. Your graph cannot get through it. Horizontal asymptotes are not the same. Horizontal asymptotes are mainly a guide for what your graph will do as it gets further away from 0. So typically when we're closer to 0, horizontal asymptotes don't do much to the graph. But when you get further and further away from x equals 0, the y-axis, horizontal asymptotes become even more important, okay? But again, your graph is allowed to cross over them, and you can see a good example of that is we have this x-intercept that is right on a horizontal asymptote. All right, so let's go to our table. Our table says that everything less than -6, we chose -8, but any number we would have chose less than -6 is negative. Okay, so anything less than negative means it's going to be below the x-axis. So we did this in the polynomial functions. But like I said, these are a little more specific because it's not only below the x-axis, but it will go below the x-axis and follow the horizontal asymptote. That's why the horizontal asymptote is there. It's the guide for the graph to follow. So then we go back to our table. Everything between -6 and -3 gave us a positive number. So that means everything between -6 and -3 will be positive, so it's going up. But it's not just going up randomly, it's going up following our guide. It will follow our guide, our vertical asymptote. everything between -3 and 1, moving on to our next section here, that's everything between the two vertical asymptotes, gave us a negative number. So that means everything between -3 and 1 will be going down. But again, it's going down in a specific way in that it has to cross through our y-intercept, and it's going to be going down. Now, when you take calculus, like I said before, these will be more specific. You will find out where is the maximum point in here, what's the highest value it will reach. You know, those are things you'll do. For now, my goal is just to get you to have a general understanding of what these graphs look like. Okay, you'll get into much more specifics when you take calculus and learn about mins and maxes and all that other good stuff. All right, the last section, everything greater than 1 gave me a positive. So that means everything has to be up here in the positives. And again, following the guides, following the vertical, it will curve and then follow the horizontal. And that is a general look of what the graph is for number 1. Moving on to number 2. Again, we're going to start this off by factoring, right? So I'm going to factor this. I'm going to do this in 2 steps. My first step, I'm going to take out a negative, okay, just to show you that it's a little easier to factor with the negative factored out front. Some of you can do this all in 1 step. Some of you need to see 2 steps. So I'm going to show you 2 steps for those of you that need to see it. So x plus 7, x minus 2 is the top, again with the negative out front. The denominator is the difference of 2 squares, so x plus 2, x minus 2 for that one. And now I will go to my list. So first off, x-intercepts. X-intercepts are where the numerator is 0. So this is 0 at -7, 0. And for now, I'm going to put 2, 0. And I'll show you why this is something different. But for now, we're just going to list it. Later on, it may or may not go away. So I want you to just, for x-intercepts, just list what makes the numerator 0. Later on, when we get into something else, this may or may not go away. Like in the last problem, it didn't go away. But in this problem, it actually will go away. So just, hang on to the thought of that one for a second. Y-intercept, again, go back and plug in 0. You're going to end up with 14 over -4, which is -3.5. Okay, if we plug in 0, like this is 0, I'm left with 14. This is 0, so 14 over -4, which again, like I said, is -3.5. All right, so here's where we're going to refer back to this issue that we just talked about. When we get into our removables, again, our denominator is 0 at -2, and it's 0 at 2. So that means 2 was a problem. This causes an issue. This is an error in my problem. And it has a repeated factor up top. So the removable is x equals 2. If that is an undefined value, it cannot be an intercept. So that's where we need to go back and say, okay, well, if it's an undefined, it's an error in my fraction, it can't be a point on my fraction. Remember, x-intercepts are points. So if it's an error, it can't be a point. So any error will overrule intercepts. So we're going to cross that guy out. It's not part of my x-intercepts. Vertical asymptote, in this case, the other one is just a -2. Okay, that's the other value where the denominator was 0, but does not have a matching pair up top. Horizontal asymptote, I'm coming back to the original. We have matching exponents, so the highest exponent on the numerator is equal to the denominator. So I'm dividing the coefficients. So -1 divided by 1, -1 divided by 1 is -1. And now I'm ready to go to my table. So, whoops, get rid of that. Get rid of that. All right, here we go. I'm going to section this off here again. So for my table, I'll try to squeeze all this stuff in here. I might erase some of that in a second. So we're going to leave a blank space. Smallest is -7. Remember, I'm using x-intercepts, removable, and vertical asymptotes. So I have -7. Then I got a -2. And then I got a +2. And I'm just gonna cross out these columns here. I don't need them for my graph. All right, so now we're ready to pick some numbers. I need a number less than -7. Let's say -10. A number between -7 and -2, let's go -6. A number between -2 and 2. Any number between, anytime you have to pick a number between a negative and positive, 0 is always the best number to use. And a number bigger than 2, let's say 10. And again, 0, I know that 0 from my y-intercept, 0 will give me a negative number. So that's negative. I already know it. I don't need to do it again. Okay, I already did the work. Don't do it again. Coming back to my -10, I will set up. Now, one thing you have to watch here is I factored a negative out. So all of these will start, when I do my fraction, they're all going to start with a negative out front from this negative right here. Okay, -10 plus 7 is a negative. -10 minus 2 is a negative. To the bottom, -10 plus 2 is negative. -10 minus 10, no, I'm sorry, -10 minus 2 is negative. So overall, I have 5 negatives, which means my answer is negative. -6. Again, when I do my table here, I will start off with a negative up top. -6 plus 7 is positive. -6 minus 2 is negative. -6 plus 2 is negative. And -6 minus 2 again is negative. I have 4 negatives. 4 negatives means positive. Last one, 10. Up top, again, starting with a negative. 10 plus 7 is positive. 10 minus 2 is positive. 10 plus 2 is positive. 10 minus 2 again is positive. So overall, this one is negative from that one negative out front there. Okay, so now we're ready to go to our graph. Let me put the graph over here. So I have a -7, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. I'll do one more. 1, 2, 3, 4 for my -3.5. And I'm going to do a +2 over there for my removable, because we'll talk about that then as well. So I have an x-intercept at -7. Right here we go, -7. I have a y-intercept at -3.5, so just put it somewhere in the middle there, roughly between -3 and -4. Vertical asymptotes. I have a vertical asymptote at -2, so there we go, dashed line at -2. Something's going to happen here at 2. We'll get into that when I get to that point. Horizontal asymptote at -1, so y equals -1. There we go. All right, now going to my table. Everything less than -7 gave me a negative. So everything to the left of -7 is negative, and again, it will follow the guide. So it's going to follow the guide and then hit our -7. Everything between -7 and -2 was a positive, so it will go up. But again, it's going up more specifically. It's getting closer to the vertical asymptote. Not going to touch it or go through it, but it will get closer to it. We plugged in 0 and got a negative. Also, everything beyond 2 was negative, so we know everything will be down here underneath the x-axis. And again, following the guides, it's going to follow up, hit our point, curve, and follow that horizontal asymptote. Okay? Now, we still have to take into consideration this removable discontinuity. Removable discontinuity shows up as a hole in the graph. This is not something that you will see when you graph this on your calculator or whatever. You won't actually see the hole, but when we do it here, this is what we're going to do. We're going to say, okay, I know that at 2, when x was 2, I had a discontinuity, I had a problem here. So what we're going to do is where x is 2, okay, right here is where x is 2, I'm going to erase that. And what I'm going to do is I'm going to fill that in with a little open circle, kind of like we did with our graphing inequalities. And we're going to do that just to indicate that there is a hole in the graph there at 2. Okay? So there is your graph for number 2 and all your parts. And again, if you need to rewind, rewatch anything here, and let me know if you have any questions.